The Islamic Golden Age, spanning roughly from the 8th to the 14th centuries, was a period of flourishing intellectual and cultural activity across the Muslim world. During this era, science, mathematics, medicine, philosophy, and literature were deeply explored and advanced. Among the most distinguished figures of this period was Abu Ali al-Hasan ibn al-Hasan ibn al-Haytham, more commonly known in the West as al-Hazan. Born around 965 CE in Basra, in what is now modern-day Iraq, Ibn al-Haytham is celebrated as one of the most influential scientists and mathematicians in history. His work laid the foundations for many scientific principles that would later be explored and formalized in the Western Renaissance. Often referred to as the father of optics, his revolutionary contributions extended far beyond light and vision, influencing mathematics, astronomy, engineering, and the scientific method itself. Early life and education. Ibn al-Haytham's early life is not extensively documented, but it is widely accepted that he received a comprehensive education in Basra, a key intellectual center of the time. He later moved to Cairo, Egypt, during the reign of the Fatimid Caliph al-Hakim bi-Amr Allah. A story often repeated about Ibn al-Haytham involves his ambitious claim that he could regulate the flow of the Nile by constructing a massive dam near Aswan. When the impracticality of the project became apparent, he fell out of favor with the caliph. To escape possible punishment, he feigned madness and was placed under house arrest. Rather than lamenting his circumstances, Ibn al-Haytham used this time to immerse himself in scholarly work. During these years of confinement, he produced many of his most impactful writings. Revolutionary work in optics. One of his greatest contributions is his seminal work, the Kitab al-Manazir, or Book of Optics. Written in 7 volumes, this comprehensive text was revolutionary in both scope and methodology. Until that time, most theories of vision followed the Greek model proposed by scholars such as Euclid and Ptolemy, who suggested that vision occurred because rays emitted from the eyes reached the objects being observed. Ibn al-Haytham challenged this perspective through rigorous experimentation and logic. He proposed that vision occurs when light rays reflect off objects and enter the eyes. This might seem intuitive today, but at the time, it was a groundbreaking assertion. His work on optics was not merely theoretical. Ibn al-Haytham conducted numerous experiments using dark chambers, lenses, and mirrors to study how light behaves when reflected, refracted, or transmitted through various materials. His observations on the behavior of light rays, the anatomy of the eye, and the process of visual perception marked a significant advancement in both physics and physiology. His experimental approach set a precedent for empirical science, emphasizing observation, hypothesis, and testing, principles that would later form the basis of the modern scientific method. Contributions to mathematics. In addition to his pioneering work in optics, Ibn al-Haytham made substantial contributions to mathematics. He showed a deep understanding of geometry and number theory, and his writings often included rigorous geometric proofs. One of his notable achievements was his early work in integral calculus. Long before the formal development of calculus in Europe, Ibn al-Haytham attempted to calculate the volume of a paraboloid, a task that required summing infinitely small parts. His use of what is now known as the method of exhaustion demonstrated a sophisticated grasp of mathematical limits and continuity. These ideas would not be formalized until centuries later by mathematicians like Newton and Leibniz. Ibn al-Haytham also contributed to algebra and number theory, particularly in the realm of solving equations. He developed methods to solve quadratic and cubic equations and studied the properties of prime numbers. His investigations into the sums of powers of integers up to the 4th power led to the formulation of what would later become known as Faulhaber's formula. His mathematical treatises often included original problems and solutions that expanded the boundaries of the field. He approached mathematics not just as an abstract discipline, but as a tool to understand physical phenomena, as evidenced by his use of geometry in studying optics and astronomy. So, advancements in astronomy. Astronomy was another domain in which Ibn al-Haytham made significant strides. He was critical of the Ptolemaic system, which was widely accepted in the Islamic world at the time. While he did not completely reject it, he questioned its internal inconsistencies and sought to refine astronomical models to better match observed data. He proposed a new model for planetary motion that removed some of the philosophical and physical contradictions inherent in the Ptolemaic system, particularly the idea of epicycles and equants. Though he did not devise a fully heliocentric model, his critiques paved the way for later Islamic astronomers like Nasir al-Din al-Tusi and eventually Copernicus in Europe. Interdisciplinary achievements. In addition to these major fields, Ibn al-Haytham also explored engineering, psychology, and philosophy. His interdisciplinary approach exemplified the holistic nature of Islamic scholarship during the Golden Age. One of his surviving works includes a discussion of mechanical devices and water clocks, indicating an applied knowledge of engineering principles. His reflections on perception, illusion, and the process of cognition showed that he considered the psychological and philosophical implications of his scientific inquiries. He believed that the pursuit of knowledge was a spiritual and moral duty, emphasizing sincerity, patience, and humility as essential qualities of a scholar. Influence on Europe and the scientific method. Ibn al-Haytham's influence extended far beyond the borders of the Islamic world. His works were translated into Latin during the 12th and 13th centuries and had a profound impact on European scholars. His Book of Optics was one of the most important scientific texts studied in medieval Europe. It influenced thinkers like Roger Bacon, Johannes Kepler, and even Leonardo da Vinci. The Latinized version of his name, al-Haytham, appears frequently in European scientific writings of the Middle Ages and Renaissance. His emphasis on empirical evidence and systematic experimentation was a key precursor to the modern scientific method, and is often cited by historians of science as one of the most significant shifts in intellectual history. Personal philosophy and legacy. Despite his monumental contributions, Ibn al-Haytham remained a humble and devout man. He often acknowledged the limitations of human knowledge and cautioned against arrogance in the pursuit of truth. He believed that all knowledge ultimately pointed toward the Creator, and that science was a means of understanding the divine order of the universe. This integration of faith and reason was a hallmark of Islamic thought during the Golden Age, and stood in contrast to the dichotomy that often emerged in later Western scientific traditions. Ibn al-Haytham's legacy is one of intellectual courage, methodological innovation, and interdisciplinary excellence. He dared to question prevailing authorities, not out of rebellion, but in the sincere pursuit of truth. He combined deep theoretical insight with practical experimentation, laying the groundwork for fields that would flourish long after his death. His influence can be traced through the annals of physics, mathematics, and astronomy, and his methodological contributions continue to inspire scientists and scholars to this day. Conclusion. In conclusion, Ibn al-Haytham was more than a scientist or mathematician. He was a visionary whose work transcended the boundaries of his time. His meticulous approach to observation, his insistence on evidence-based conclusions, and his integration of philosophy and science set new standards for scholarly inquiry. As one of the towering figures of the Islamic Golden Age, he reminds us that the pursuit of knowledge is a noble endeavor, one that can illuminate not only the mysteries of the natural world, but also the higher truths of existence.